So I hope you guys like this question so far. And now let me explain how come we end up with two different answers. And we know this is certainly not the same as that, right? And let me tell you, in fact, we make a technical mistake, and I did that on purpose to test you guys, okay? So whenever we integrate, we get a function for the answer, but what else do we need to put down? Well, we need to put down a plus c for a constant, isn't it, right? And let me just emphasize the plus c is after the inverse cotangent, so let me put a parentheses around the x. And likewise, we also need a plus c right here, plus c, and then let me put a parentheses around the x. And we know this plus c, this constant, it's not necessarily as the same as that one. So I should put this as c1, and this is the second constant, so I'll put down c2. And now I can tell you this, it's actually okay to be the same as that. They are just off by a constant. And now let me go over the secret behind all this with you guys. If I put these two together, let me write it down right here for you guys. Inverse cotangent x plus c1. I do have the right to put them equal to each other with this. Negative inverse tangent x plus c2. And what I would like to do is, I would like to move this to the other side. So let me just show you guys all the computational work real quick. So this is a good old, algebra style. You add inverse tangent x on both sides, isn't it? So that you can cancel, huh? And then I want to subtract c1 on both sides, so that I can cancel, huh? Right here, on the left-hand side, we have the inverse cotangent x plus the inverse tangent x. Okay, this is equal to, here is the fun part. C2 is just a constant, subtract C1, which is another constant. The answer for this is what? It's just going to be another constant. You don't need to put down C2 minus C1. We can just put down another constant, and I'll use C3 for that. Okay? And now, as you can see, when you have this plus that, altogether you end up with a constant. So what's that magical constant right here? I can tell you real quick. This C3 right here is pi over 2. You actually know what that number is. How do we know? Well, you can check on my other video real quick. If you read this out loud, this is cotangent, right? This is the cotangent, but it's the inverse version. And then this is the regular tangent. My other video explained how do we end up with the cofunctions. When you have sine, how come we have cosine? And what does cosine do? When we have secant, we have cosecant. And what does cosecant do? And right here, we have tangent and cotangent. What does the cotangent do? So here is a deal from that video. You can just watch it and you will know. How do we end up with the cofunctions, the name co? It's because two angles add up together to be 90 degrees. And 90 degrees is exactly pi over 2 radians. When you have two angles, they add up to 90 degrees. What do we call that? They are complementary angles. CO, complementary angles. That's how we end up with cotangent. Okay? And then remember, when we have inverse of anything, it represents an angle. This also represents an angle. Co and then the regular together, they add up to be 90 degrees, which is pi over 2. Okay? So as you can see, this is the connection, and you can look at this a couple different ways. You can also look at this as inverse cotangent x, which is the same as pi over 2 minus the regular inverse tangent. Okay, this is perhaps the most important one in my opinion. Okay, because if you want to find the inverse cotangent, what you can do is you do pi over 2 minus the regular inverse tangent. And now you see, when you differentiate this, you get that. And you can also differentiate the right-hand side. This constant will go away to be 0. And then you do have the negative right here. And then the derivative of the regular inverse cotangent, the regular inverse tangent is that. So you have this all together. And they are the same integrals in the first place. Okay. So once again, to wrap up, the answers, right? they are just off by a constant. Don't let the functions part right here bother you. Remember to put down a plus c, then we can be legitimate, okay? And you can put down either one for the final answer. You can put down this one for the final answer, or you can put down this one for the final answer. Sometimes you may work on integral, but then somebody else may have the different looking answer with you. Don't ever fight with other people. It's just off by a constant.